the building detection. First of all, let's upload this code to Google Colab building segmentation. I can just drag and drop, then it will be, I have already uploaded it, so I'm going to use it here. And first of all, we have to run the prepare input, this notebook. It's already open here, so I'm going to use it. Okay, uh, in Google Colab, the GDAL will already be installed, so we don't need to do install it. But if you are using it in your local machine, you might have to install it following this instruction. First of all, we have to uh, mount the drive, and also we have to make this root dir path match with our current directory structure in Colab. So uh, it's already mounted in my case, so even I'm running it again just here. It's already mounted, and this root dir should show this building segmentation copy path, this one, building segmentation path. And if we copy the path in this way, copy path, then you can see root underscore dir equals, okay, this is the path. And make sure that you add this slash also, so that our root dir becomes complete. Next, it's already mounted, so next let's move on to next step. Let's run it. Okay, I'm just running it. And next, here we are giving this JPN dummy path for input, and then this is the building.jpg inside this JPN dummy, and the output will be saved in input raw max and input raw image directory. Let's run it. Okay, now it's created. Let's refresh this, and you can see input is, you can see input, it's already created over here. Next, we should convert this data into COCO format, and we are going to use this cv2 counters.ipython notebook. So for this, if you have not installed this modules, you have to install it. I have already done it, so I'm not going to rerun it. So next, you have to load this, import the libraries. Next, let's move on. And similarly, as we did in our previous notebook, we have to set the root dir accordingly, like we did before. So okay, it's already mounted. So again, next, it will this code will run, and it will prepare building directory, which will be having COCO data format, data in COCO data format. Let's see. Okay, we have already, this notebook is already executed, and this building folder is created. Inside building, we have training set and testing set. From the images that we have got, we have created 70% of images for training and remaining for testing. If you wish to control that, you can check this function here, divide train test dataset. Here the default is given 70% training, so you can change it as you, if you wish. So the execution of this notebook completed. So next, we are going to move on to building instance segmentation. This notebook here, Detectron2 library is used for building instance segmentation. If I refer to these two links, and particularly I got this example, and I modified this example for our case. And also, let's first we have to install the libraries and dependencies. I have already done it. You can run it there, and Once you have installed it, you might have to restart the runtime. Okay, then let's do okay. And then after restarting the runtime, you can run it. Okay, you can run this, and you can check the current environment that we are using. We are using PyTorch 1.8.0 CU101, and we have CUDA version 101 here. Okay, next we are going to okay mount this directory, already done for our case, and then we have to get the data and import the libraries. And this is our data dir. That means this is the building data in Coco format. We have to copy the path and keep it here because our data is there. So okay, then okay, then you can run it. Then this dataset should be registered for Detectron2 to use for training. So here our images, each of our images are of 512 into 512 size. So make sure you match this. Next, our train and test path are matched. Then uh, our we are testing one of the images from training set and just displaying it here. This is the one of the images, and the annotation for each images where we have identified buildings. Here we are using the training set and just displaying it here to see. Next we have to do the train. I'm not going to run it now because I have already done it. It will take some time for execution, so I'm just explaining it here. You can see I ran this model with this configuration for 100 iterations. And please note that since we have only one class, that is building, I have written it 1 here. Just note it. Other things, we are just using max rcnn, uh, so you can change if you wish. So then I ran it. The training is ran, and it took some around 8.5 minutes to complete this. And once that was completed, I tested it for with testing set, and we found okay, I can rerun it because the it will use the trained model. And you can see, yeah, your building detection is done with the trained model. And here we can see the cars and roads are not identified, but the buildings are identified. You can see it's pretty accurate, even though we have not done any fine-tuning or modification for adapting with our problem, but it's already giving a nice result. But we can do more fine-tuning and make it better. Okay, in this way our demo completes. Thank you.